Hello, I hope you're doing well today. This project explores how accurately an infrared sensor and an Arduino can measure glucose values to make a non-invasive continuous glucose monitor. Diabetes is something many people struggle with throughout their life. The blood glucose values need to be checked frequently, and not enough people have access to insulin, leading to long-term health problems developing. Personally, my grandmother has diabetes, and I can see how it affects her life, making her sacrifice precious moments. The development of a non-invasive continuous glucose monitor can help many people who have diabetes lives easier, including my grandmother. To test this, I formulated the research question: how accurately can infrared sensors and an Arduino measure glucose levels to make a non-invasive continuous glucose monitor? I used my independent variables, which was the glucose levels, and my dependent variable, which were the amounts of IR light being recognized. The controlled variables were 0, 50, 100, 130, and 150 milligrams per deciliter of glucose. These ranged from no glucose, low, normal, pre-diabetic, and high levels of glucose. To test the accuracy, I made a circuit that could read the amount of IR light being absorbed. I then made a stand to stabilize the infrared sensor and receiver and emitter, so there was a gap for the vial that contained the glucose. I did calibration tests to find the rate of change between the actual glucose value and the amount of IR light being recognized. Using the analog read code, I put the designated amount of glucose into a vial that contained water and placed it between the IR emitter and receiver. I plotted these points on a graph and used the line of best fit to get the equation to plug into the code to change the value that was being displayed on the Arduino serial monitor to be an estimated glucose value instead of the amount of IR light being recognized. The accuracy of the glucose monitor can be seen based on how close its estimated glucose value is to the amount of glucose there actually is. My photos show the materials, the code, and the circuit in working. In my calibration data graphs, you can see as the amount of glucose increases, the amount of IR light decreases. In my actual tests, you can see that how close the actual glucose value is to the estimated glucose value. The results from this experimentation show that an infrared sensor and an Arduino is a fairly accurate way to make a non-invasive glucose monitor. The R-squared product was 0.965, which was fairly accurate. I noticed a pattern while completing my experimentation. Usually, the amount of glucose in the vial, if that amount of glucose was greater, then the amount of IR light had more of a variation than what was being recognized. I also noticed a few anomalies. One of the significant anomalies was that during the 130 milligrams per deciliter test of glucose, the estimated glucose value was less than the actual glucose value, while usually in all the other tests, the actual glucose value was but the estimated glucose value was greater than the actual glucose value. I also had a few difficulties. During the testing, I used a petri dish at first, but the IR light wasn't being absorbed by the small amount of glucose it was going through. So I replaced this with a narrow tube that could let the IR light go through more glucose. I also hot glued the IR emitter and receiver onto the stand for better readings. I was supposed to test the glucose in synthetic blood, but while testing, I noticed that the IR light being absorbed was the same no matter how much glucose I added. There is no reason for this occurrence, but it could be because of a pigmentation or a chemical not reacting with the glucose correctly, or the IR light being absorbed by a chemical or substance in that glucose. If I were to redo this project, I would use a 12-bit Arduino that has higher sensitivity to the amount of IR light changing. I would expand this project by adding an insulin pump and finding a way to test the glucose in synthetic blood. In conclusion, this experiment shows that glucose values can be accurately sensed by infrared sensors and an Arduino to make a non-invasive continuous glucose monitor. These findings are just the beginning of a much larger idea that can lead to a new technological medical breakthrough. Thank you for listening to my presentation.